Okay, good morning. Hey, Matt. Do you have any specific question at this time? Hopefully somebody else is going to jump into this conversation, but make sure that you type in any kind of a question that you might have regarding this chapter or other chapters. Okay? But this week we have to start working on Chapter 6. And in Chapter 6 we talk about user-defined functions. So far we have heard of and we used other people's functions. So we looked at the math library, and we also looked at some of the strings. And of course in Chapter 3 we looked at the input and output modifiers, right? Especially the output modifiers when we have to include the IO manip library. So how do those functions actually work? Or do we have to always rely on somebody else's functions? And of course not. I mean, people write those functions, so that means in any programming language you can write your own functions. And because we're talking about functions, using the compiler, and especially the debugging feature of functions, is going to be even more important. Okay, so basically functions are modules. So here in C++ we call them functions. In Java we'll call them methods, but they all accomplish pretty much the same thing, which is doing something specific. So they're like miniature programs. There are a set of statements. They have their own design, their own little flowchart or pseudocode, if you want to call it that way. But they usually accomplish just one single thing. And the reason for that is so we can divide and conquer a larger problem. So what do I mean by that? Somebody that, let's say, write or builds a furniture, that person is not really sufficiently skilled to, let's say, to kill the cow, to skin the cow, to prepare the leather, right? Then construct the frame hopefully out of wood, okay? And then design the couch, and then build the frame, and then basically cover it with leather, right? So you don't want to do all that. You want to specialize in, let's say, in design, or you want to be specializing in one particular aspect of, let's say, furniture building. And that's where we're going with modules. You want to specialize modules. So when we're talking about predefined functions, the main thing that we need to understand that predefined functions have a name and they do something. And as they do something, they're going to return something else to us. So what I like to think of when it comes to functions, okay, so we have this kind of, let's say, a watering can, okay, and something goes into the watering can. Inside the can, I don't really care what's inside the can, and I know something's going to come out of it. Okay, so the can has a name. So far, the function that's been most familiar with is called main. Now, what goes into main? Well, so far it was just empty parentheses. But this is where we can actually put in what we call parameters. And when we have parameters, we're going to separate the parameters with commas. So And then what comes out of it? It does something inside the main, right? Whatever we write, whatever fits our pseudocode and flowchart. And what comes out of it? As far as we are concerned right now, an int data type comes out of it. So it's not a variable that comes out, it is a data type, a value that comes out of that watering can. So if you look at predefined functions, let's look at square root. Okay? Now how does square root work? What does it need? Well, it needs a value, but what kind of a value? Well, we might have to go to the documentation to find out what the square root need. In general, what I'd like to do is open up the IDE as you learn about new concepts in a chapter. So let's see if I can just switch over to my IDE. Okay, so if you look at my IDE, right, there is a program, and let's say we're going to include or import let's say the CMet library, okay, and then we go down to our function, okay, and in the function I type in POW, there, so it's a little bit larger. Okay, so as soon as I type in POW, then you can see that we have 7 different ways how we can use POW. So here what you need to look at is, what do you mean by parameters? Well, in this case, we still need to look at the watering can. Right? So we can look at the watering can. So what goes into the watering can? What comes out of the watering can? Okay. I don't really care about the details, what the can does, but in order to use this, I need to know its name. The name is POW. Okay, and then I look at what does it take, what kind of an argument does that take, what is it that I need to send to this function in order to do its job. Now, if POW raises a number to an exponent, so that means I need to have a base, comma, exponent. So I don't know how it does it, right? You might not even care how it does it, but it cannot do its job until you send this function a base and an exponent. And what comes out of it? What comes out of it is a value that is raised to an exponent. That the base is raised to the exponent. That comes out of it. So now, what is it that I need to send? What is that base and exponent I need to send? So as soon as I put in the open parentheses, in Visual Studio, it has a side program that runs all the time, which is called IntelliSense. Now the IntelliSense actually tries to help you as a programmer figure out how to use a function, so you don't have to go to the internet or somewhere else to research it. So as you can see, in this particular case, POW is the name of the function, and what do I need to send? The base can be in double, and the exponent can be in double. And what comes out of it? Well, whatever data type is in front of the name, see how it's separated by a space. That's what comes out of the function. So I'm going to receive a double. At this point, if I just press the up and down arrow, okay, we can go through, we can just cycle through all the different ways how we can call, how we can use POW. So let's go back to the first one. So first one parameter is double double, and I'm going to receive a double. Second way would be double is the base, integer the exponent, and double would be the result. In this case, we're sending POW float, receiving float, and the base and the exponent both has to be in a float data type. Or we can have float, the base, and integer exponent, but we're going to receive out of this function a float data type. Okay? So in this case, you have a long double. This is kind of like a longer number. So we haven't really focused on this in this chapter, but we don't need to go into much of a detail. Just make sure that you understand that long is still going to be a longer integer. Just the size of it is going to be longer. But the exponent can also be a long. Okay? So long double, long floating point will come out of it. Or what we can do is long double comes out, but we need to send a long double as a base and the integer as a exponent. Right, so that way, if you say 10 comma 2, right, then it is a proper function call, because this way you can see that we have the POW, and the POW is called with an integer comma integer. And you can see in this IntelliSense, as it shows you that +7 overloads. And that's what we're going to be dealing with in this chapter. What do you mean by overload? The overload is the same function, but different parameters. So like in our case, we can have POW with int comma int, or float comma float, or double comma double. But the name of all of these functions are exactly the same. So the compiler will pick which one is appropriate. But if we're going to be, let's say, what happens if we are sending, there's still going to be an integer, let's do string, right? So it's going to be, I'm using POW, and I'm trying to send an integer, comma, string. And now it says there is no instance of this overloaded function. So I don't know how you can call this. I don't know how to handle a string as an exponent. So that's not going to work. Okay? But that is the basis for what this chapter is about, these functions. But first we need to understand how to use somebody else's functions. And as you can see, at this point, what's going to make more sense after this chapter is how to read any kind of IntelliSense or other documentation related to somebody else's functions. So this chapter is going to be very helpful for you to understand programming. Okay, so in this case, you can also see that my main function has actually an argument list. Okay, and in this chapter or in this class, we don't really worry about this because we don't know much about this type of a notation, the asterisk, and then we have the, later on, we'll learn about what an array is and the array value indexing. And if somebody asks me a question, I mean, we can talk about that and we can look at how that works, but it's not part of this particular class. Okay, so let's see if there's any kind of a question so far. Okay. Okay, good. Okay, so these are the predefined functions, right? And think about it like a box. Something goes in the box, something comes out of the box. Multiple things can go into the box, but we need to know the order and the data type of what goes into the box. And only one single thing gonna come out of the box, no list. Okay, so predefined functions are organized into separate libraries. So I/O functions are in the I/O stream header, so in that library. Sometimes the author kind of intermixing these definitions. Okay, headers are holding the actual code and specialized functions, and a group of headers is grouped into a library. And when we say CMAT is a library that holds header files. Okay, so let's go back to our IDE. Okay, so here's the CMAT, right? If you right-click on CMAT, and then you need to open up the document, CMAT, it takes you to that document, to this ugly thing. Okay. But if you look at what CMAT does, look at all these .h files, right? And you can see that there is the mat.h file. .h is the header. So you can see that a collection of headers, see there's a bunch of header files, and all those header files are collected, and they are in that CMAT library. Okay. So you can look at some of the details, and you can even look at the I/O stream, right? Right-click on I/O stream, open the document, and if you scroll down a little bit, okay, even if you look at just simple variables, right? We talked about that CI and COut is not a predefined or a reserved word. Those are just predefined variables. Why is it predefined variable? You can see that this is where CIN and COut comes from. It's kind of ugly and complicated structure, IU or data type, but you don't need to deal with it because it's already in the I/O stream. So as soon as we say include I/O stream, we can use the simple version of it, which is just referring to the variable. So it's easier to use. Okay, so to use predefined function, we must include the header file and the include statement. So that's going to be processed by the preprocessor. Okay. So returning functions have return types, but void functions do not have return types. They do not need to have the keyword return. But if you have a returning function, then you need to have the return keyword used and return the proper data type. So value returning functions, to use functions, you must include the appropriate header file in your program using the include statement. Know the following items: name of the function, number of parameters, if any, data type of each parameter, and the type of the value returned by the function that you call. And that's what we saw with POW, right? So we can have something like float POW, right? And then we can send the float base and the float exponent, right? Now, float is the return type, and then you have the parameter list that that shows you the base. Okay, so there's a base, and you might have the exponent separated by the comma. And sometimes it's not very intuitive, right? So that's why you might go to, I don't know, www.CppChapter6.com. Is it actually going to come up? Let's do let's get Google. Okay. Okay. There it is. So we can just go to CppChapter6.com if it comes up. Okay, let me share the desktop then. What's wrong with this today? Oh, there it is. Eventually this will come up. Now let's say I don't know how to use POW. You can just search for the function, POW. And I believe this is a much better documentation for each functions, right? In the IDE, when we looked at POW, if you look at the POW right here, it just shows you data type and then X and Y. And you might say, what do you mean by X? What do you mean by Y? I don't know what that means. Here, you have a better documentation, shows you that the first parameter is a base, and the second parameter is the exponent. You have a better, more humanly understandable explanation for the parameters. So you have the base and you have the exponent. It gives you a little bit of description, and also it gives you an example code. So on this website, it's kind of like your book. When the author talks about a concept, it gives you a sample code, and then gives you a sample run and the sample output of that code. So so here you can see that you can just copy and paste this code into your compiler, run it, and then that way you can learn how a function actually operates. So it's a very good website, very good reference site to go to. So it will be CppChapter6.com. Okay, so we have a return value, and what do we do with that return value? Well, we can saving it for further calculations. We can using it in some other calculation, or we can just print it out directly. It's up to us, up to the code, how you're going to handle it. But if it's a value returning function, if something comes out of it, you should be handling that value. Even though sometimes you can ignore it and the compiler not going to complain about it, but if you need to know that if it's a value returning function, you should do something with the value that comes out of it. Yeah, I mean, all the functions that we're going to be writing, we're writing the function within our single source code. Okay, so later on I can show you how that works. Okay, where the header file is. The header file is the same thing like your source code. Okay, you save it in the same place where you can distribute it. Okay, the predefined header files. What we use is just when we type in include, right? You use the greater than sign and the less than sign. Now, if it's going to be your defined headers, okay, what we're going to do is we're going to use the string notation, the double quotation, to show that this is my header file. But that's more of a advanced concept, so we're not going to go into that. Maybe in the second lecture we can talk about it. But there's a lot more concepts. There's going to be a lot more complicated just to understand how functions work than to actually look at where they're stored. So make sure that you understand that it's stored with your source file. But as far as this class is concerned, all of our functions are going to be in our source file. Okay, so as soon as we start writing it, you're going to see that it's not going to be separated from our source file. Okay, so value returning function. Let's say that the absolute value. You can see that it takes one single parameter. It's an integer type, and what comes out of the ABS, which is the absolute value, is also going to be an integer. Okay, so when you have formal parameters, okay, and that's going to be an important concept. If you have formal parameters have their data type with them. So if you have a formal parameter, okay, you have the data type and the parameter name. If it is the actual parameter is just the identifier name. Okay, so when you, in this case, what we're going to be calling this is the call. Okay, this right here, this one line, we're going to call that the prototype. So in the prototype, we're going to be using formal parameters. When we're calling the function later on, the calling is going to be actual parameters. Okay, so that's going to be important. That terminology is going to be important. So how do we create a value returning function? Well, first of all, what comes out of it is going to be the return type. Now the return type going to be the type of the function. So a function type is, if it returns an integer, it's an integer function. If it returns a floating point, then it's a floating point function. So the function type is the return value's data type. Then you have the function name, and then in the parentheses we have the formal parameter list. So what do we need to have? The formal parameter list contains the data type and the name of the identifier. And the function has a body, and with the function body you have statements. That's when you actually do the work. So that's when you have the function return type. In this case, is an integer. Function name is ABS. Then we have the formal parameter. Formal parameter is including the data type of the parameter of the identifier. If it's a list, if we need multiple, then we separate them by a comma. Then we have the function body. The function body is the opening and closing curly brackets. And then we have statements in there just like you would have in any other program. That's why we call this like a miniature program. At this point, think about it like it's the main function. But because it is a data returning function, you need to match whatever the data type that comes out of the function. You need to make sure that that is the same data type that goes out of the function. Okay? So if you look at your main function return type is an integer. What is it that we return? We return 0 normally, right? So long as the value that we return is an integer, then it is a proper return value. Now, do we have to return 0 from main? No, it's just a convention to show everybody or show the other programs, show the other the operating system or the user that everything went fine. So by convention, 0 means everything is okay. So then we have the function call. Now with the function call, we have the function name, and in the parentheses, we have the actual parameter. So we don't need to specify the data type because actual parameter can be an actual value or maybe an identifier. Well, you can't really use an identifier until you declared that identifier. At that point, you already specified the data type. So in the function call, we do not deal with, or we don't worry about the data type. Actual parameter list, either an expression or a variable separated by the comma. If you have multiple, then we call it a parameter list. Now the formal parameter list can also be empty if you don't want to send anything to the function. Again, think about main. Main is just a empty parameter list. Right? We have nothing, normally we have nothing in between the parentheses. When you call a function without any parameters, you still have to show the parentheses. Okay, so you cannot ignore the parentheses even though the parentheses are empty. And then we have the return statement, and that is the value that we pass outside the function. Now when we're talking about a return statement, the return value, as long as it's a proper data type, it can be any expression. So when the return statement executes, that means you are returning back to the calling function. So that means you are done with that particular code and somebody else will take over. So if you put in POW in your main function, then POW will be called. When POW returns a value back to main, then POW goes away, right? We don't need it anymore. So it's kind of like, I think we kind of covered that when we started the semester and we started looking into how computers work. Okay, so let's say we had main. Main is the function. Okay, and in main we have, let's say, x and y, and in main we might call, let's say, function 1. We're going to call function 1 with x and y, separated by a comma. So let's say x is 5, and then we're going to have y is 10. This looks like 16. I want to write 10 there. Okay, so what does that mean? Now locally, okay, let's say it's my main memory accessible by main function. Okay, Now, what is a variable? A variable is really just a pointer, a reference to memory address, right? So when we said x equals 5, what really happens is somewhere in main, in the memory address reserved for main, we're going to say 5, and for y, we have another memory address where we're going to say 10. And then we call function 1. Now, function 1 doesn't exist. Then we call function 1. What happens is main goes to sleep. And when main goes to sleep, then function 1 gets loaded into memory. Now, function 1 is called with x and y. Now, in function 1, we might call it a and maybe b. Okay. In this case, a going to have 5, and b going to have associated 10. If function 1 is defined as a comma b. Why is that? Because here, when you look at it, okay, so as far as planning the code, now we have to look at how do we do this? How do we put this into our flow chart? Okay, so a lot of people do it differently. Okay, most people would use this box and you have 2 bars on 2 sides. But if you guys are going to take Java, what you're going to be using is UML. So with UML, it looks like this. It's a horizontal bars. Okay. So the top bar, you put in your function name, that's F1, and the bottom part is your, let's see, your return type. Okay. So return. So here in the box itself, I can show that whatever the x is, I'm connecting to A. Whatever the y is, I'm connecting that to B. So that's kind of like a visual representation. So you can see that x is the first parameter in the list. Right? So x is the first parameter in the list, and A is the first parameter in the actual function. So that's why I'm showing that x is connected to A. Okay, so that's going to be easier to read for somebody. How does your function receive some values? By the way, so function 1 is called with a copy of x and y, and now the copy of x and y is called A and B. And then you do whatever calculation you have to do. Now let's see what happens if function 1 needs to call another function. Let's say function 2. And I'm going to call function 2 with a parameter b. Then what happens, f1 goes to sleep, and on top of f1 we create a memory area reserved for function 2. Now function 2 receives a value, now let's call it z. So if we are, let's say, using z, and z gonna be the parameter that function 2 receives, then we're really making a copy of whatever b is, and making a copy, storing it in z. And then function 2 does its job, goes to the return statement if it's a returning value returning function, and at that point function 2 is destroyed. It's gone. At that point, function 1 wakes up and continues on with its operation until it reads, or it gets to the return keyword, or gets to the close curly bracket. At that point, it goes away, it's destroyed, and now we're back to main, and then main continues on with its job until it finds the return keyword. If the return keyword is executed, then the application goes away, right, destroyed, and then we are back to the operating system. And then in the operating system, now you as a user, you can launch another application or launch the same application again. Okay, but that's the basic set of executions as function is going to be called. Okay, so if the function returns a double, then we have a local variable or a result of an expression, but it needs to be a double or something that fits into the double, and then we can return that value. And that's where we're going into things like the prototype. Okay, so the prototype will have the formal parameter list, and the return type of the function and the function name. Okay. So the problem with now the understanding like selection statements. When we have selection statements, and that's why you do not want to start writing the code until you actually designed your code. So let's say with secret, what's the problem with secret? Now if you start writing the flowchart for secret, okay, we start it and then we have an if statement, and if the if statement is true, then we return from the if statement. But what happens if it's false? If the if statement is false, we have no clue what's going to happen. So there's nothing returned from the function, because in this case, remember the selection statement does not guarantee that each branch of the code going to be executed. So if the selection statement logic goes to the true side, it's fine because you're going to return something. But if the selection goes toward false, okay, there is no false block. So that's a bad code. And you would catch that at design time. So if you designed it properly and you plan the code, then you're never going to make that kind of a mistake. Okay. So in this case, the correct way, as you can see that we have now, in the second example, you have the selection statement. And if the selection statement is true, now you return something. If it's false, you still return something. So that means you accounted for each one of the ways in the selection statement. So that is properly coded design. Now if we are returning something, remember the watering can. The watering can only return one value at a time. So if it only returns one single value, then what happens with this statement right here? Now this statement, anything that's comma delimited, there's a list with a bunch of commas, C++ will see it as a list. Now within this list, which is a proper syntax, so it's not going to be called by the compiler. If it's a proper syntax, and the data type of the variable is proper, then you're not going to see any kind of a syntax error, but only one value will be returned from that list, and it's going to be the very last value in that list. Okay, so same thing with the second example. Okay, the language will see the syntax as a proper syntax, but only Z plus B will be returned. Okay, so anyway, this should be enough for one day to get us started. So let's switch over to our Visual Studio and maybe write a couple of these functions so you can see how that works. So if you go to the Visual Studio, let me just clean this up. it. Okay, so we don't need any of that. Let me get rid of this one so you guys don't get confused by that. Okay, so that's a very basic hello world. Okay. Let me get rid of all this too. Because we don't really need that anymore. Right? You guys understand how that works. Okay, so we have a basic code. Again, just like with file operations, you need to look at it as a recipe. Okay, so what is the recipe? Okay, let's say let's create a simple program. Okay, so we're gonna have cout, and we say hello world. Right? So we always create a simple hello world program. Okay, now in this case, it is called right here from main function. But I have other things to do, and I'd like to say hello world many times in my code. And I don't want to always type cout hello world, cout hello world. So what can I do? I can break this into a function. So how do we do that? Let's do step one. Okay. Step one is we need to have a prototype. Okay. Now, what is the prototype? Prototype is the function type, then function name, and then, if any, then we have, it is the parameter list. And then we have to have the semicolon at the end of it. Okay? So how do we do hello world? Let's do a non-value returning function. What is that? That's a void function. Why is it a void function? Because we use the keyword void as a return type. And then I'm going to say, I can come up with any name. Now, what determines what name I need to use? Well, a function is an identifier. So the function name is going to have to follow the same rules like any other identifier. We can start it with a number, right? We can use digits, and we can use characters. We can use the underscore, but by convention, we don't start the identifier name with a convention. So if I'm going to call this my display, then I'm still following the naming standard of camel casing. Okay, and then we do not have any parameter list. Okay, and now we put in the semicolon. So now we have a function. Let me just show you this. Okay, as soon as we have the step number one completed, as soon as I start typing my, look at that, there is my display. Okay, so I can look at that my display, put in the open parenthesis, and you see how the IntelliSense picked it up right away. Now this function is available not from the library, but from my own code. IntelliSense tells me, now what kind of function is that? Well, it's a void function. I know that is not going to have any kind of a return type. And you can see the name of it. You can see that it does not require anything. And you can also look at and see the comment. You see how the comment also shows up? Okay. So IntelliSense picked up these two lines and trying to help me use that function. So I don't have to look it up. Okay. Anyway, so what is this going to be? let's hang on to that to define what we did over here. Usually, you can see that we have a function, but it has no body. It doesn't really know what to do. Okay? So I would like to say that step number 2 is, okay, so step number 2 is to implement the function. Okay? So how do we implement it? We're basically copy pasting whatever the prototype is, so the return type, the name of the function, and the formal parameter list. Okay? If we would have a parameter, that would be a formal parameter. And now we give it a body. And usually what you would do is you would normally have the prototype before main function defined, so IntelliSense can pick it up and show you how to use that function. And then after the main function, you would actually give it a body. At this point, I can just cut cout hello world from my main program, and I don't want to do anything else, just display hello world every time somebody calls this function. Okay? Now we have the implemented function. It does everything what I want this function to accomplish. And that's when we go back to the main function, to step number 3. And this is where we would say call the function. So this is the 3rd step. That's all we need to do. Have a prototype, give it some name, whatever name you want, implement the function, and then call the function. Okay? So if I just use the breakpoint right here, okay, or maybe I can put it inside the function as well, so I can show you when we are in the function. Okay, and then we run this code. You see how we stuck right here? We are in that function right now. Okay? And because we passed line 17, we displayed hello world, but now the function displays hello world, not main. Main only calls the function. So what happens at this point? Main is asleep, right? Main is asleep because we called something else, and the computer can only do one thing at a time. So because we are in function myDisplay, we displayed hello world, and we are about to return back to main. So if we continue on, now you can see that we are back into the main function. Okay, so let's just stop this code, and let's add something else in here. Let's say int age 5. Okay, and let's say int age 20. Now you can see that there is no conflict, so there is no complaint about having the same variable. Why not? Remember the drawing that I had? When we call a function, it creates its own local variables, okay? Its own scope of the variables. So let's see what happens here. Okay? Then we run the code again. Okay? Now you can see that we are in the main function. Right? So if we click on locals, what do we see? We see age. What is age? Age is 20. So which age am I looking at? I'm looking at age, which is in myDisplay. Can we see age in main? No. Main is asleep. We actively looking at myDisplay. So I continue on. At that point, age from myDisplay and myDisplay altogether is gone, and now main woke up And since main woke up, when I'm looking at age, now age is referring to 5 because age, local variable in main, is equal to 5. Okay, so let's create another function. Okay. Now, if we want to have another function, we need to change what? Step number 1, which is a prototype. Okay. Let me change this function, myDisplay. MyDisplay will receive an integer, and I'm going to call it, let's say, 8. Now, this is a different prototype now, right? It's still not going to return anything. But in order to call it, now we're going to have to call it with a parameter. Okay. So now that I try to call, let's say, I'm trying to call myDisplay, and I put in the open parenthesis. Now it says we have 2 implementation of it, right? And one of them says void myDisplay int a. The other one is still saying that there is one without any parameters. Okay. So now what I need to do is I can type in, let's say, 25. Okay. So now if you put your cursor on myDisplay, you can see that IntelliSense shows you that void myDisplay with a parameter int a is called. See, it is the formal parameter what IntelliSense actually senses or reads. But we still don't have the proper implementation of that function, so we need to go back and say int, and I'm going to call it value. Okay. Now what happens when I look at myDisplay? You see the prototype identifier is overwritten by the actual implementation value, the implementation identifier. Even IntelliSense does not say int a anymore. It is looking at the actual implementation of the function, and it says int value. So what does that tell us? We don't even have to have in the prototype the actual identifier names. We can just have the data types in the prototype, and it will still work. Okay. And if we do have the name in the prototype, the identifier, it doesn't have to match what's in the body of the function. Because that's where we're actually creating a local variable. Here, we're just saying, well, we're going to have an integer called something. Here, in the body of the function, now we have to have the actual function name that we're going to be handling. So now here, I can say, instead of 20, I can say value. So what happens? Whatever I call the function with, that function value is going to be sent to myDisplay, and now that value is going to be assigned to my internal local variable. And again, you can run this. And you can see that the value and age is 25, but value is right here, what we received. What did we receive? We received the copy of what was defined in main. Now this is a literal value. Long as it's an integer data type, I can also say just age. And now, because age is an integer, the function expects an integer. Function handles the integer. Then the function call, as long as the data type is properly formatted, it can be used to call a particular function. Okay, so let's change again this this function that we have, and let's have a value returning function. Okay, so let's go ahead and return an integer out of this function. Okay, step number 1, define the prototype. Now I have an integer returning function. Step number 2, I need to give it a body. So now I have an integer returning my display that also accepts a value. So that means because now it is a value returning function, it needs to use the keyword return, and let's return, I don't know, 2015. All right. Now what can we do? So here we can also say, okay, now we have a value returning function. So now we have step number 4. Now what is step number 4? Handle the return value. Okay, so we need to handle the return value. How do we handle the return value? What comes out of it? An integer, right? We can just say int x equals. Okay, what else can we do? We can use it in an arithmetic, right? We can do 20 divided by whatever comes back from my age, right? Because it's just going to be an integer, right? Whatever is returned, let's do 2015, okay? So whatever is returned from the function, well, it's an integer, so it's really going to be integer divided by integer. Okay, what else can we do? We can also just print it out, right? So we can just say cout, okay, your age is, okay, cout can handle an integer, right? So we can just send that directly to the cout, because cout will see that, oh, integer comes out of it. Well, it doesn't really matter. It would be the same thing if somebody would say, you know, but you're 34 years old. Okay? But I don't know how old are you, right? Because whatever this function will return to me, that's going to be the value that I'm going to be returning. Okay, so let's stop it at both places. So you can see this is 1, 2, 3 function calls. Okay, and we can also have an expression. Then we are calling a function, right? And then maybe age divided by 2 or something. Okay, so we can have a literal value. We can have a literal value sent. So let's say 40, literal value, or we have an expression, or we can just have the value of a variable, and we can either just assign the return value, use it in an expression, or we can just print out the return value. Okay. Let's stop it in each one of those. And before we return, okay, we also need to stop that in that function call. So use the debugger for your advantage, right, to understand how this actually works. All those little red dots will help you understand how this works. Okay. So right now, we are about to call the function. You can see that age is 5. X and Y still hold garbage values, right? We haven't called the function yet, so we haven't initialized the variables. We only declared the variables. Continue. We are in the function. In the function, we are calculating something, right? We also have an output to the screen for the user, and then we are about to return a value. When we return the value, now you can see x is equals to 2015. Where did that come from? Well, that was the return value from this function call. That function call assigned x 2015. Now we are about to call the second function call. Y is still garbage value. Continue. We are in the function. We are about to return 2015. Okay. And you can see that we returned 2015, but we added 30 to the age, so we used the return value, which was divided by 2015, and that return value expression resulted in the calculation 1. So now y is not a garbage value. We are about to call the function again. So as we continue, you can see now we call the function. The function did not remember any previous values, so you can see that the function my display is created and destroyed as we are calling it. So the value in age is 2 at this point. Okay. At that point we are returning 2015. So when we are returning 2015, okay, then we have to display it. Okay. So you can see that finally, after the third function call, we also display something from main, and the return value is displayed. All the hello worlds were displayed from the function itself. Okay. So you can see that the function is within our source code, right? So we don't have to save it somewhere else. It's not a separate file. Everything is in one single source. And that's what you're going to do in your assignments, okay? One CPP source file, and all your function calls are going to be within that. But when you implement that function, first you start with the prototype, and then the body of those functions is going to be outside of main in their own implementations. So until Wednesday, I just want you guys to practice this, okay? So the first couple of days reading through this chapter, only know this, okay? Write the simple hello world, break out the hello world into a function, call that function, and as you're calling the function, make sure that you're using your breakpoints, okay? And put in a couple of variables just like we did today, so you guys can see what function you're in, what code is executing at that point, and how does this work, how does function call business work in C++, okay? And I don't want you to go any deeper into that. Just have these simple function calls, okay? So, now you cannot call the function before you have the prototype, but you can call the function before the implementation, okay? So some people put the implementation before main. What I like to do is have the prototype before main, and then the implementation of each functions after main. Remember, it's going to go through preprocessor, so it doesn't matter where the function body is, before or after main, it's going to be processed by the time you're looking at the calls, which are inside main. So the preprocessor will process the actual body of the functions. The 2015 doesn't really mean anything, right? You as a programmer, you are designing, by design, you basically specified what is the value that you're gonna be doing. What is the value that you're gonna be using? And that's what we did in assignment 1. When we returned 0 or we returned 2015, it doesn't really matter. As long as it's a data type, but then somebody supports this application, okay, they will need to know what return value you returned, because we're going to return different values based on how our code branches. Okay, so let's say if we have, you still see my screen, right? Okay, so let me see. If I try to do a copy a.text to b.text, okay, it says, I cannot find the file. It doesn't exist. And if I do echo error level, you can see it returned 1. Okay, so the code, the copy code actually branched. So okay, this is not 0. This is something went wrong. Well, what went wrong is the user, I display a message to the user, but to the operating system I send a 1, so if some other application wants to use the result of the prior application, they will know that something went wrong. So if I create this file, let's say copycon a.text, and I'll say hello. So now I do have a.text. Now when I say copy a.text to b.text, it says 1 file copied. If I look at this, and I look at echo the error level, now you can see that the operating system sees a 0. So what that means is the application executed properly and returned 0. And if they return anything but 0, that's an error condition. That mostly means something to engineers or technical support. Usually the users will not look at what an error level is. Okay? But basically, the basic idea is that you as a designer, you determine what the return value is in main. In functions, okay? In functions, we need to know what is it that we are returning. So, or why are we returning? So if I would call this function, let's say my ABS. So if this is going to be my ABS function, and let's just change these. So that's going to be, let's say, minus, and I have ABS, my ABS, and this is my ABS. Okay. Now, what is it that you want to return? Okay. In this case, I don't want to say hello. Okay. I just want to do calculations, right? So what happens when I receive this value? What is it that I need to look at? Well, what I need to look at is if value is less than 0, right? If value is less than 0, what do I need to do? I need to return minus value, isn't it? I just multiply it by -1 and I return it. So that's going to be a positive value, right? Else, what you want to do? You want to return the value itself. Why? Because the value is positive. So if the value is positive, I don't want to return anything. So in this case, the return value is the actual result of what this function is supposed to do. Okay? But if the function doesn't really does anything specific, like main, we don't know what main does. What does main do? Well, it's just a program. That's my program. Main needs to return something. Okay? If I get to the end of main, that means everything went fine. So now I can return nothing. I can return basically 0. 0 means I got to the end. If somewhere, okay, so maybe you would say if age is greater than 200, well, it doesn't really mean much, so maybe you would say return 2015. Okay? In this case, we are terminating the program early. If we're terminating the program early, is because some error condition happened. Okay? Age is greater than 200. And maybe for some reason, I cannot use this program. But anyway, so in this chapter, you need to look at all the source code, run the source code, and it's going to make more sense how the functions work. Okay? Make sure that you read the chapter and run the source code and bring in more questions next time when we meet about this chapter. Okay? So we went a little bit over, so make sure that read the chapter, run the source code, compile the source code with the breakpoint set, and then see how it goes. If something doesn't work, then bring specific questions in so we can address those on Wednesday. Okay? So that should be it. So see